Okay, so hello everyone. My name is Omm Animesh Mishra, and today we are back with the second lecture of our series Structural Analysis, and the topic of today is equilibrium. Okay, so this is one of the most basic and important topics in this chapter in this course. So we'll be learning it today. Okay, so I'm a BTech second year in IIT Roorkee in civil engineering, and the structural analysis course is very important, as you all know, for the structural design course as well as the industrial applications, including the important questions in the exams. Okay, तो आज जो हम लोग टॉपिक पढ़ने जा रहे हैं दैट इज इक्विलिब्रियम. तो लेट्स जस्ट रिवाइज व्हाट वी नो अबाउट इक्विलिब्रियम फ्रॉम आवर प्रीवियस क्लासेस, राइट? तो हम लोग को जब इक्विलिब्रियम समझ में आता है देन व्हाट वी थिंक दैट अ बॉडी इज एट रेस्ट. If this body is at rest, then it is an equilibrium. Equilibrium is defined in many ways, like if the net force on the body is zero, then it will be staying at rest. Okay, then it is said to be in equilibrium. Okay, अब equilibrium के भी दो तीन types होते हैं, दो types होते हैं. तो equilibrium will be unstable and stable. तो हम लोग देखते हैं. This is basically just the revision because we know all these things. If this is a ball of mass m, and here also this is a ball of mass m, right? तो इसका यहाँ पे लगेगा weight and इस ball का लगेगा यहाँ पे weight. So if we apply a force here, then this ball will go here, but still the weight is acting downwards. Therefore इसका weight का एक component, one component of its weight will pull the ball downwards, right? Will pull the ball downwards. So the weight is acting as a restoring force. So if there is a restoring force, then equilibrium can be maintained, and it is known as a stable equilibrium. Stable equilibrium. Same about this. अगर यहाँ से भी हमारा force लगा जाए तो ball यहाँ तक जाएगी, but still the mg will pull it down, and this is a stable equilibrium. Okay. Now for the unstable part. Let's see. अगर यहाँ पे किसी ने force लगा दिया F, then the ball will go somewhere here, but still the mg is downwards and no other forces are acting on it, so it will move infinitely downwards, making this an unstable equilibrium. Okay, so these are the basic types of equilibrium, or this we know from our previous classes. Now let us apply this concept to the today's structure course and see that what happens when a structure is in equilibrium. Okay, so a structure or one of its members is in equilibrium when it maintains a balance of force and moment. In general, this requires that the force and the moment equations of equilibrium be satisfied along the three independent axes. Okay, so we have three axes. Whenever we try to think about the action forces on a rigid body, then we divide them in three directions. Okay, x, y, and z in a 3D space. So if we have a beam, let's suppose we have a beam and it has force F on it, then what we can say that this whole structure will be in equilibrium if summation fx is equals to 0, summation of forces along x direction is equals to 0, summation fy equals to 0, summation fz equals to 0, and not only this, the summation of moments along x, y, and z must also be 0, right? So this will be considered as a equilibrium structure, and then we'll be able to say that this structure is an equilibrium if these all conditions are satisfied. Okay, so now let's move on and see. If the principal load carrying portions of most of the structure lie in a single plane, and if the loads are coplanar, then okay, so if the loads are coplanar, let's take the same example as we took. तो उसमें क्या था कि we had a roller support here, we had a hinge support here, we had a force here. Okay, तो हम लोग ने FBD बनाना तो सीखा था पिछले क्लास में. So now we have a force like this, a force like this, a force like this, and a force like this. तो रोलर की वजह से एक ही डायरेक्शन में रिस्ट्रिक्शन हो गया मूवमेंट का एंड फॉर अप इन टू डायरेक्शंस आर ब्लॉक्ड. ठीक है, तो दो फोर्सेस एंड रोलर के लिए एक फोर्स. नाउ अगर हम लोग अच्छे से देखें तो दीज ऑल द फोर्सेस आर लाइंग इन द एक्स वाई प्लेन. okay, x and y plane. So these can be termed as a coplanar forces. और अगर forces coplanar होते हैं then we don't need the z direction. तो z direction में तो the equations that we wrote earlier, there are 6 equations, so now they will reduce to 3. Okay, so they will be summation fx is equals to 0, summation fy equals to 0, and summation moment around z is equals to 0. क्योंकि मूवमेंट तो z के लॉन्ग आएगा. इफ द फोर्सेस आर इन एक्स वाई प्लेन देन द मूवमेंट विल बी इन z डायरेक्शन, बिकॉज मूवमेंट क्या होता है? मूवमेंट इज द क्रॉस प्रोडक्ट ऑफ फोर्स एंड डिस्प्लेसमेंट, एंड द दिस इज आल्सो नोन एज द लीवर आर्म. हम लोग ने ये तो मतलब लोअर क्लासेस में पढ़ा ही था. सो दिस इज नोन एज द लीवर आर्म, एंड द मूवमेंट विल बी इन द प्लस z और द माइनस z एज in accordance to the thumb rule. Okay, ठीक है. तो now we understood the basic equations involving equilibrium. Now let's move to the next part, which is drawing FBDs. So we have been drawing FBDs from 11th and 12th. We have drawn a lot of FBDs. Okay, but now what we are going to see is what to do when a structure is given. अगर आपको एक structure दिया गया है तो how will be drawing its FBD? तो draw FBD बनाने का एक बेसिक तरीका होता है, दैट इज कोई भी एक मेंबर को हम लोग सिलेक्ट करते हैं फ्रॉम द स्ट्रक्चर एंड देन वी आइसोलेट इट, और जितने रिएक्शंस और जितने इंटरनल फोर्सेस हैं विल बी इंडिकेटिंग देम ऑन द कंपोनेंट. ओके, सो दैट इज द बेसिक FBD. सो लेट्स ट्राई टू मेक वन. सो दिस वी हैव एन एग्जांपल हियर. तो अब हम लोग क्या ट्राई करते हैं? लेट्स ट्राई टू ड्रॉ इट्स FBD बाय कटिंग इट इनटू 2 पार्ट्स. ओके, अगर हमने यहाँ पे एक सेक्शन ले लिया, ओके सेक्शन हियर, तो हम लोग को 2 पार्ट्स एक्सपोज हो जाएंगे. दिस इज पार्ट 1 एंड दिस इज पार्ट 2. अब हम लोग ट्राई करते हैं दोनों की FBD सेपरेट बनाने की. ओके, सो इफ दिस इज पार्ट 1, तो हम लोग देख सकते हैं उसके लेफ्ट साइड में वी हैव अ फिक्स सपोर्ट. ओके, सो दिस इज द मोस्ट रेस्ट्रिक्टेड सपोर्ट एंड इट रेस्ट्रिक्ट्स एवरीथिंग, राइट? इट रेस्ट्रिक्ट्स एवरीथिंग विथ मोमेंट्स एंड फोर्सेस. अब जिस पार्ट को हमने कट किया है, सो देयर विल बी 3 मोर फोर्सेस देयर. प्रीवियसली हम लोग ने ये भी पढ़ा था, हम लोग ने ये तो पढ़ा ही था कि वी हैव, अगर हम लोग किसी भी पार्ट को कट करते हैं देन वी हैव 3 फोर्सेस देयर. सो व्हाट दे आर अ shear force, we have an axial force and a bending moment. Okay, so if this cut portion is m, then this will be my, mx and we'll have an mm of moment. Okay, so cut करने के बाद we can draw its FBD. Similar होगा, most likely the mirror image will be the second part. Okay, और हम लोग को यहाँ पे ये ध्यान रखना होगा कि we draw just the opposite forces because they will be equal in magnitude. Equal क्यों होंगे? Because at that joint there is no movement, so all the axial, normal and the moments must be 0. क्योंकि rigid body है, ना ही उसको हम लोग rotate कर सकते हैं, ना ही we can stretch it, we cannot do anything, right? So moments will also cancel and they will be equal and opposite on 1 and 2. Okay, so we drew a basic FBD. We understood how to draw the FBD in a section. Okay, so let's go a level up and try to draw the section FBD of this structure. Okay, so this looks a bit complicated now. So we need to understand that all the joints are pin joints except the one at C, because this is a roller joint. Right, we can see that this is a roller. Everything is a pin joint or a hinge. Okay, so let's try to do this and we'll draw everything. हम लोग सारे components के FBD बनाएंगे on all the components, right? Like pin joints, हम लोग joints के ऊपर भी force दिखाएंगे and structure के ऊपर. Mostly हम लोग को joints के ऊपर force दिखाने की जरूरत नहीं पड़ेगी, but we need to understand how the third law works. Third law, what the third law states? Third law states that action and reaction pairs are equal and they are equal in magnitude and opposite in direction. ठीक है, so let's try to draw this FBD. Okay, so let's try to first separate it into components. ठीक है, तो we have this, we have a component like this, we have a point this, and this can be drawn a little bit better, I think. Like we can just such that it looks like it's coming from the same point. Okay, and we have a point C. So A, C, D, B, E. Okay, so D, we have a point here that is D, B, and we have here E. Okay, so now let's try to draw the ability. So these all A, B, and C are support reactions. D and E are also supports. They are joints, basically they are joints, but we can treat them as supports. ठीक है, तो अगर हम लोग बनाना चाहें तो this A is a pin joint, right? तो pin joint में दो forces होंगे. There will be AY and AX, right? अब जब हम लोग इस पे बनाएंगे, this point, this is also connected to A, but this will experience the same but opposite forces because the net force must be 0. तो दोनों में equal and opposite forces लगेंगे. Similarly for D, D के लिए we'll be having a dy and a dx, and this point will experience the equal and opposite forces because net force must be 0. Okay, dy. Okay, now this point B, BB or a pin supporter, then we have by, we have a bx, we have a bx here, and we have a by here, equal and opposite on all the points. These are joints and these are supports. Okay, so this point E, this point is also connected to B. तो what we are having, यहाँ पे हम लोग देख सकते हैं D मेंबर पे एक P1 फोर्स भी है, राइट? सो दिस फोर्स विल गो हियर P1. ओके, और उसके बाद वी हैव BE मेंबर पे वी हैव दिस, ये तो हमारा जॉइंट था, जॉइंट में फोर्सेस आ गया. नाउ दिस पॉइंट, actually this is not a joint, so we cannot actually separate out. This is a component, right? तो let me draw it clearly here. So यहाँ पे हम लोग यहाँ पे फोर्सेस नहीं दिखाएंगे. We will be showing the forces in this E part, right? क्योंकि this is a pen, this is a fixed joint. So joint, this will be the point where we will be experiencing the opposite forces, right? Like so. Because this will join to this, then by cancel, bx cancel, equal and opposite. ठीक है, तो similarly E पे force will be EY and we'll be having an EX. The same will join in this. These are not actually supports, but we are treating them as pin supports because they are similar. Okay, so EX and EY. Okay, and now for the last part, C. We have CX and we have CX here also. Okay, now we have drawn all the forces. Let's see if we miss something. P2, yes. So P2 is somewhere here, right? Okay, all the forces are being drawn. Now we can apply the equation of equilibrium for all the forces, right? So like this is a component, this is a isolated component we have here. This is an isolated component we have here. Okay, and the last we have here also. So these are components among which we can apply the equations of equilibrium to get the individual forces, because P1 and P2 are known, so we can explain all the forces on basis of P1 and P2. Okay, we can just write summation fx is equals to 0, summation fy equals to 0, summation mz equals to 0, and find out the value of all the forces that are here. Okay, so I can leave it as an exercise for you to find all the forces. This is relatively very easy, and you might not be able to find all the forces, but you can at least represent them on in terms of P1 and P2, right? So I hope you'll try this, and that's it for today. So if you want to know about the 9-pointer community, then you can scan this QR code. You can also join our Telegram channel, and if you learned something from the video, then please make sure to like it and subscribe it, and I'll be seeing you next time with new lectures and a new topic, right? Thank you.